All right, welcome to the second video of 1.2. This one should be pretty nice. We get some visuals. We get to see some things. We're going to be talking about how to find the equation of tangent lines graphically, all right, and some graphical interpretations of some things. So we're going to start off with a little secret, okay? A little foreshadowing, all right? If any of you have had any exposure to calculus before, you might see what's going on here, but otherwise it's going to be a surprise for later. So here we go. The slope of the graph y equals x squared at the point x comma y is given by an equation. Okay? The slope of this parabola at any point x comma y, we have a formula for that. This formula I'm going to call f prime. So that's a prime and it's pronounced f prime of x is equal to 2x. And again, don't spoil it for anybody else, but this is the formula for the slope. Okay? We have a function y equals x squared. We have a formula for the slope of that function, f prime of x is equal to 2x. All right? Because the slope of a curve is the slope of the tangent line. All right. If you can just like record yourself saying that the slope of the curve is the slope of the tangent line and just like play this over and over and over again while you're sleeping, that sounds like a great strategy. All right. Never forget it. So let's look at some stuff. Okay. With example 3. Yeah, I'm not writing this out. Although I'm encouraging you guys to write it out, but I'm not going to write it out. So, hey, get back there, tablet. This will be example 3. So find the slope of the tangent line at the given point and find the equation of the tangent line. So I hope you're ready. Hope you love tangent lines. So part A is going to be the point -2 comma 4 on the curve y equals x squared. Oh my goodness, I cannot draw a 2 to save my life today. Okay, so let's see. What do we need to find? What is it asking us to find? 2 things. First, find the slope of the tangent line. Well, the slope of the curve is the slope of the tangent line. So how do we find the slope of this curve? Well, we use this handy dandy formula we got up here. The slope of that curve is given by that formula. So we need to find the slope, okay? We need the slope of y equals x squared when x is equal to -2. Right? Because to use this slope formula, what's the input of that formula? The input of that formula is x. So we need to figure out what our x value is. And here our x value is -2 because this is our point. So we'll use that to find the slope. Okay, well, the slope using that formula is going to be f prime of 2, which is equal to 2x, and x is 2. So the slope of the tangent line is 4. All right, we've already finished the first part. The slope of that tangent line at that place is 4. And congratulations, you're already done with 1.2 for this problem. Because what else is next, right? It's also asking you to find the equation of the tangent line. Well, we already have the slope. We already have a point. This is 1.1 all over again. Use point slope form. Okay, so next, right, we need the next thing that we're doing is we need to find the equation of that tangent line. So we have the slope, right? The slope is 4. We have a point on the tangent line, -2 comma 4. So let's just use our handy dandy formula. We'll be good to go. That's going to be y minus y1. The y coordinate here is 4. This 4, not the slope 4, is equal to our slope, which we also said was 4, times x minus our x value minus a negative 2 is the same as plus a positive 2. Okay. So there we go. That's the equation of our tangent line. And if you wanted to rearrange it, you don't have to, but if you did take some steps and rearrange it and solve for y, you'd get y is equal to 4x, and then plus 8 plus 4, I believe, is plus 12, is what you get if you solve for it. And let's say that you say, I don't believe you, Jason. You made a mistake in last week's video. You wrote a positive 3 instead of a negative 3. You've lost all mathematical credibility. Well, you don't have to take my word for it, because I'm going to show you. So let's look at this function, y equals x squared. What are we asking? We're asking, what is the slope of the tangent? What is the slope and the equation of the tangent line at this point? Point 2 comma 4. We got it right here. Ooh, technology. All right. And we said the answer. We said the answer was y is equal to 4x plus 12. And you might say, Jason, this looks nothing like a tangent line. It doesn't look anything like a tangent line because I did make a mistake. And kudos to you if you got it, okay? Right? The slope's all wrong. Right? We got a problem with negatives, all right? Because what did we say? X is negative 2. So we should be plugging in negative 2 right here, okay? Plug in negative 2 right here. Should get a negative 4. This will be a negative 4 as well. And so when you end up solving the equation, you're going to get that y is equal to negative 4 minus 4. Negative 4x minus 4. And this is why it's so great to check your answers, guys. Because you can visually see what's going on, and you can know whether you're correct, because look at that. Is that not the most beautiful tangent line you've ever seen? Remember, tangent lines are just lines that just skim right up next to it. If you really zoom in, whoa, this kind of looks weird. If you really zoom in, they almost look like the same. And if you zoom out, you can see more accurately what's going on. Tangent line is just a straight line that just kind of skips right next to that. All right, so we checked our answers. We can see that this is actually the equation. We actually got the right equation. You can see it right here. Okay? So, check your answers. It's a good habit to be in, especially if you have a habit for dropping negatives. Next part, part B, is also going to be y is equal to x squared, but this time it's at the point where x is equal to 2.1. And if you hate decimals, I've got bad news for you. This class has a lot of decimals, okay? Because this is a class about applications. And we of course, haven't gotten to many applications yet, but we will. And unfortunately, in the real world, we have messy numbers. So better get used to it now. Suck it up. It's a great thing to tell your students. And that's where we're at, okay? So again, we need the slope, right? We need the slope, so we're going to use our slope formula from before, right? This nice slope formula is what we're going to use. F prime of x is equal to 2x, all right? So f prime of x is equal to 2x. And here is the point where x is equal to 2.1. So we have to plug in x is 2.1. That's where we evaluate the function. So it's 2 times, I believe, a positive 2.1, which when you work that out becomes 4.2. That's our slope. And that's where we're at the start, guys. Part 1. Well, what else were we asked? Well, let's look back at the problem. Problem said find the slope of the tangent line. The slope of the tangent line is the slope of the curve. And so we use the slope formula. And again, this is only a slope formula for this specific function. Next, find the equation of the tangent line. We'll use point slope form again. So, oops. So we have the slope. We're just also going to use the point. We know the point when x is 2.1 and when y is we have no y. And the last time they gave us the whole point. Here we only have the x coordinate, right? We only know the x coordinate. We don't know the y coordinate. Well, it's your lucky day because we have this nice relationship between x and y. It's the function, right? So we don't know y. Well, we can find it out, right? Y is equal to x squared. Let's go do that. Y is equal to x squared. So when x is 2.1, y is going to be 2.1 squared, which is, I actually don't know this. Is it 4.21 maybe? 2.1 squared. Oh, 4.41, not even close. All right. And it is positive. It's positive, right? So that's the y coordinate. So we'll just plug that in. 4.41. And that's where it comes from. So we know the slope. We know the point. We can find the equation of the tangent line now using point slope form, which again is y minus y1 is equal to m times x minus x1. The y coordinate is 4.41, just like we found before. The slope is 4.2. And the x coordinate is 2.1. And again, at this point, you should have absolutely zero faith in me. And you should say, you should demand, you should be sending me an email right now. Jason, I demand that you check your answer right now. Well, today's your lucky day because I will be checking the answer. So we could add that 4.41 to the other side and simplify. But let's check our answers over here. So again, it's the same function, but now it's at the point when x is 2.1. And when x is 2.1, we said y should have been 4.41. And yeah, it looks like that's on the graph, sure. And we said our tangent line, I'm not going to simplify the whole way. It was 4.2 times x minus 2.1. And then it was also plus a 4.41. Oh, thank goodness. I did it. I did a problem from 1.2. Whew, there it is. That's a tangent line. Like, it really just sidles right up to that. It's kind of satisfying to see, you know? And again, there's a bunch of different ways that you could express your answer, but you check your answer. All right, I haven't introduced this website officially, but this is the website, by the way, desmos.com. I would highly recommend it. You can't use it on like exams, but it's a great tool for a homework, for visualizing things, checking your answers, etc. Or if you could check all this with a graphing calculator as well. Anyway, highly recommended resource. Let's do the last problem for this video. And again, if at any point in any video you say, okay, I got this, I'm going to start the homework. You can pause the video, go do the homework. And if you say, oh, I need to see more examples. Well, here you have them. All right. Last example of the day. Example 3. Well, maybe not last example of your day. Last example of this section. Example 3. Find the point on the graph below whose tangent line is parallel to y is equal to 2x. This problem has a whole lot of meat in it. This is a juicy problem over here. And so this problem would have, I will have given you a graph. Well, let's not use green. I'll have given you a graph. In fact, this problem is from the book. And it's the graph of y equals x cubed. Looks something like this. And the slope is f prime of x is equal to 3x squared. So notice that this different function, it's not a parabola anymore, this different function has a different slope function. There's going to be something to that, okay? The slope of the tangent line is the slope of the curve, and this slope of the tangent line is also something else called, spoiler alert, a derivative. All right, so there's a lot to unpack here. There's a lot in this problem. Wait, there's also information missing. No, I don't think there's information missing. All right, we'll find it. All right, so let's get into this. There's a lot going on. So here's what we're looking for, right? We're looking for a point. That's our end goal. And what do we know about this point? We know its tangent line is parallel to y is equal to 2x. There's a couple of things going on here. So first off, what does it mean to be parallel to y is equal to 2x? Parallel means the same slope, right? If you have two lines that are parallel, that means they have the same slope. Again, that's important to know. Well, what's the slope of this graph? Well, remember y is equal to mx plus b, where m is your slope. This is y is equal to 2x plus 0, so our slope must be 2. The slope of a line is just the number next to the x. So the slope is going to be 2. So we've now utilized this piece of information. The tangent line is parallel to y is equal to 2x. So this is that slope. We also need to incorporate the fact that we are looking for a tangent line. Okay? And the point has to be on the graph, right? We're looking for a point on the graph. So all points on the graph are the points x, comma y. Right? And specifically, we know what y is too, right? Y is equal to 2x. This is kind of an optional step to comment on this. Okay? So we need to find the points on the graph that have a slope of 2. Right? Let's always go back to the problem. If you're stuck. Find the point on the graph whose tangent line has this slope. All right, so when is the slope equal to 2? When is the slope of the graph equal to 2? That's what we have to ask ourselves next. All right, when is the slope of the graph equal to 2? Well, the slope of the graph is the slope of the tangent line. And the slope of the tangent line we said was 2. That's where this comes from. We also know the slope of the graph is this. The slope of the graph is going to be 3x squared. Okay. All right, slope of the graph. When is that equal to 2? Well, the slope of the graph we just said was 3x squared. So what we're really wanting to know is when is the slope of the graph equal to 2? When is the slope of the graph equal 2? And this is the multicolor, that's multi-hued equation. When is the slope of the graph equal to 2? Well, this is the slope of the graph. This is 2. When are they equal? We got an equation to solve on our hands. How fun. So we need to solve for x. Let's divide both sides by 3. We do that. We're going to get x squared is equal to 2/3. We square root both sides. Remember, when you square root both sides of an equation, you do need a plus or minus. Plus or minus square root of 2/3. I'm actually getting really nervous. Did I make a mistake here? I didn't think the answer was so messy. So it's parallel to this. And is it equal? So the slope of this is 2. Just like so. So you use the slope function, which is 3x squared. Solve for when it's equal to 2. Well, we'll check our answers at the very least. So no need to get worried. And so it's going to be the x coordinate. So to find the y coordinate, you just plug it into the original function. At this point, we need the y coordinate. Well, y is equal to x cubed. So it's going to equal plus or minus square root of 2/3 cubed, which is kind of a messy number. I'm not going to make you rationalize the denominator though. But one way you could simplify this is plus or minus square root of 8/27. Again, it's not fully simplified, but I really don't care that much. I'll accept this as a final answer, even though there are much better ways of expressing this, right? You could write this as plus or minus 2√2 over 3√3. You could rationalize the denominator after this. Again, it's really not the important thing. So what is important is our final answer should be a point. So it's going to be when x is the square root of 2/3. And when y is 2√2 or 3√3. Whoa. And it's also going to be the point when x is negative square root of 2 over square root of 3. I'm not being perfectly consistent here. We do have 2 answers here. And of course, we'll have to check our answers and make sure that I didn't do something silly with a negative again. This is not actually our answer over here, but I want to be a little careful with erasing it. Let's check our answers. Let's see what we got. All right. So what we're doing is we're looking at the graph. Y is equal to x cubed. And specifically, we want to know when the slope of this is 2. And we said the slope is equal to 2 at these, at these 2 points. Square root of 2/3, comma. The y coordinate we said was 2 square root of 2. Actually, it's a little easier to just write it this way. Square root of 8 over 27. So first things first, it is very important that this is on the graph. And then we also want this to have a slope of about 2. So we can check our answer by putting this in point slope form, right? Square root of 8 over 27, that's our y coordinate. The slope, we hope, is equal to 2. And the x coordinate is square root of 2/3. Is that a tangent line at this point? It sure is. Does it have a slope of 2? It sure does. Good. And then we should also have the same point, but negatives. Again, notice this point is on the graph. That's good. Does it have a slope of 2? Well, let's look at the equation of the tangent line. Y minus the x coordinate, or y minus the y coordinate, which is already a negative, it's going to be a positive 8 over 27, is equal to the slope, which hopefully is 2, times x minus the x coordinate, which is also negative, so it becomes x plus the square root of 2/3. And again, we've got a beautiful tangent line with a slope of 2, exactly what we wanted. So even though you're looking at this and you're saying, this is such an ugly answer, it's a correct answer. All right, and that's how we can visualize it. And this video ended up being much longer than I wanted. This is really going to become a theme. Y'all are just going to have to get used to long videos, or I'm going to have to split them up even further. But this will be an interesting experience for all of us together, because there's still 1.3 for this week as well. Anyway, please let me know if you have questions. Please let me know if you're struggling with any of this. This material is foundational for the future. So it's incredibly important to have a mastery of it and be very comfortable with this. Maybe not this last problem. This last problem really is kind of like a bonus problem for, hey, here's a messier problem that you could see, as opposed to the meat and potatoes of the earlier problems. Okay, so if this one's confusing, it's not too big of a deal. Obviously, it's best if you do spend time to understand it and do similar problems. This one came from the book. I think one of your homework problems is very similar. I don't think I actually stole this one directly from the homework, but you could see something maybe like this on a quiz. Although it'll probably have a little simpler of calculations. But anyway, if you're ever curious about what the quiz expectations are, if you're ever curious about how I got to something, you can comment on the video in Canvas Studio. You can ask me on Slack. You can send me an email, all this stuff. Anyway, good luck. And I sure hope you're not watching this on Wednesday. Anyway, bye-bye.